So now we're going to look at how we can get x values, given those same sort of things we saw before, and actually the process is the same. It's just that because the book thinks you're going to use the table, it's wrong, but it's what it thinks. There's sometimes an added step here. It's worth knowing for an understanding of how z-scores work anyway, because if we have that a z-score is determined by x minus mu over sigma, we could just as easily say that if we know a z-score, the x value is given by mu plus z times sigma. So for a quick example of how this computation works, say a veterinarian records the weights of cats treated at a clinic, where the weights are normally distributed with a mean of 9 pounds and a standard deviation of 2 pounds. And we want to find the weight that corresponds to the z-scores of 1.96, negative 0.44, and 0. Where, to make this translation, to go from z-scores to specific x values for that distribution, just use that formula there. So in our first case, if z is equal to 1.96, I don't know why I put 99, 1.96, I'll just plug the numbers in. X is going to be given by mu plus z sigma, where here we have that mu is 9. In this case, our z value is 1.96, and we have said that sigma is 2. So you multiply that out, you add that up, and you get an x value of 12.92. For our second case, z equals negative 0.44. It's not that different. We have x is equal to mu, 9, plus z, which here is negative 0.44, so we're going to end up subtracting something, times 2 again. In this case, multiply out, subtract, and you get 8.12. And then finally for our third case, when z is equal to 0, hopefully you shouldn't need to do math for this, but it's good to be reminded of how this works. X is equal to the mean mu plus the z-score of 0 times the standard deviation of 2, but 0 times 2 is 0. So we just get 9. And like we say, the z-score of 0 corresponds to the mean, so we just get that x is the mean, as we should expect. And this is what you'd have to do as part of the problem should you want to approach these with the table. You would have to find the z-score that corresponds to the given area and then convert that z-score into an x value doing this. So it's an extra step on top of being a bit ambiguous, but use the inverse normal function in the calculator. It's more efficient, and that's what I will focus on doing when we look at our examples for how this stuff works next.